Hello everybody, good evening. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. In this particular lecture, I am going to talk about some previous year GATE questions on tree data structure, and this is the part 2 of tree data structure PYQ series. So in this particular session, why it is important, just because I am going to express you the way of solving the question. I am not going to only explain you the solution, but I will explain you that how you can approach the question after reading the question, and that definitely will help you in your GATE exam preparation. Why? Just because if you learn how to solve a question, then you will definitely be able to answer most of the questions of those topics which you know, which you understand. So without any delay, let's get started with this particular special session. Let me introduce myself first before we go further. I am an educator of Unacademy. My name is Vishvadeep and I have written GATE exam multiple times. This is my rank, highest rank till now, 19 in the GATE in my final year. Before that, in the third year also, I have written the GATE exam with the rank 682 and some other ranks 119, 440 I am having. Masters, I went for my masters to IIC Bangalore, another masters in BITS Pilani. This is the experience I am having, and these are the courses I am taking right now on Unacademy's platform. If you guys are seeking for more quality content, then here it is on Unacademy's platform. Go to Unacademy platform either by web browser unacademy.com or through Unacademy's learner app and search my profile Vishvadeep Gothi. You can go through this particular URL also. There in my profile you will be getting special classes. This special class is very special just because these special classes are free. So there are so many special classes I am taking live, and there are so many special classes which I have already taken, and those you can listen in the recorded mode from Unacademy's platform. So go to Unacademy platform and access these free contents. To access the free content, you will require a code, and this is the code VDEEP10. This particular code is the unlock code for multiple things, including your free content on Unacademy's platform. So go for this particular code and you will be able to access Unacademy's platform for free also for all the special classes. If you want my already taken special classes in more organized way, in a structured way as a playlist, then you can go to this particular URL. Check out once, you will get a lot of content over there. If you guys want to have a free test series, then here it is, a free test series from our end. This particular test series is free and a quality question you will be getting over there. So enroll for this test series and you will be getting a really great questions for solving over there. But if you are seeking for any great platform for learning, then here it is from our end, my team's end, you guys are going to get, and that is Unacademy Plus. What is Unacademy Plus? Unacademy Plus provides you that environment which is essential for any kind of test. Which test? Any kind of test? No, the test which requires very high level preparation. So getting best rank, best marks in the GATE exam is not only knowing the topics but knowing how to target the exam, and that is what exactly we will provide you on Unacademy Plus. So 60% it helps to know the knowledge or to know the topics, but 40% it helps that other personality things, other things which are required for your any kind of test preparation for getting highest marks, and those 40% extra things we will provide you on Unacademy Plus by training you using the live classes which are very interactive, by training you by every week test, by giving you training, by solving your doubts, and multiple more things. So if you want to go for Unacademy Plus subscription, then this particular Unacademy Plus subscription is coming into the multiple different packages. It can come in 24 months, 18 months, 12 months, 6 months, 3 months, 1 month package also. It depends on what kind of preparation you want, but let me make sure you one thing, that if you are really a great aspirant, if you are really a sincere aspirant, then imagine this particular thing, that 12 to 13 subjects you cannot prepare in just very few months span. So if you are preparing for any kind of preparation, any kind of gate exam, suppose you are going for gate 22 or 23 or whatever, take a longer period. Start from today, as soon as possible you start, and make your preparation rigorous from today, so that at the end you will not struggle with your preparation plan. So take the subscription. For subscription, if you use the code VDEEP10, you will be getting a discount of 10%, plus you will be getting some extra added benefits. What are those benefits? My mentorship. Okay, why my mentorship is required? Just because I can help you with those extra 40%, which can help you to gain more marks even with the limited knowledge also. Second thing, I can help you with lot in your preparation journey. Other than that, this particular code can give you a bridge, a particular connection with your preparation to my team's effort. There is a team which is working in and out a lot for your guys' preparation, for you, for your success, for your preparation. So if you want to connect with my team, then you need to use this particular code VDEEP10 for your subscription. If you want that, I don't want any headache, other than the preparation, then you should go for Iconic subscription. This Iconic subscription will be including all the facility of Unacademy plus extra facility of personal coach. This personal coach will provide you preparation strategy. So if you are not good enough to have the plan, to get the plan done, then this particular personal coach will help you for the same. So personal coach will prepare the preparation strategy personalized for you, will prepare the study planning for you, will give you study booster sessions, personalized test analysis, and preparation material also will be provided to you. So if you want to go for Iconic subscription also comes with the discount if you go with the code VDEEP10, and other benefits also included in this. Remember the code VDEEP10. This particular code will unlock lots of benefits if you use the code VDEEP10. Okay, fine. So any kind of learning will always have the great intentions. So if you are having a good intention of learning, then you need to let me know. Regarding the same. So if you are having great intentions, then let me know. If you are ready or not, just let me know. If you are energetic till now for your learning, let me know by typing in the comment box. Ready or not ready? Are you ready? क्या आप तैयार हैं? अगर आप रेडी हैं, जल्दी से कमेंट बॉक्स में मैसेज कर दीजिए you are ready, and then we will start the questions. So very first question of the day, question GATE 2002. Very simple question. Let's try to understand what it says. A weight balanced tree is a binary tree in which for each node, the number of nodes in left subtree is at least half and at most twice the number of nodes in the right subtree. So it's very simple that if we have a node in the left subtree, we can have half of the nodes of the right subtree, or we can have maximum twice of the nodes of the right subtree. So one side you will be having one portion, other side will be having the double of that portion. So if suppose you have x number of nodes in the right subtree, then in the left subtree you can have either 2x number of nodes, or you can have x by 1 by 2 of x nodes. So let's take total n number of elements. If you are having total n number of nodes, then how you can distribute those n number of nodes? If total n number of nodes you are having, suppose right side you are having x and left side you are having double of that, means I can go with this कि right side you are having x number of nodes, left side you are having 2x number of nodes. Total how many number of nodes you are having? Total number of nodes you are having is x plus 2x plus 1 is equal to n. This is given. Now the question is the maximum possible height of such a tree on n number of nodes is best described by which of the following? Which of the following? The best possible, maximum possible height. Now look at this. If I am saying one side you are having x number of nodes, other side you are having 2x number of nodes, then means whichever side you are having more number of nodes, that side height will be more. Whichever side is having more number of nodes, that side height will be more. सिंपल. अगर लेफ्ट सब ट्री में ज्यादा नंबर ऑफ नोड्स हैं तो हाइट ज्यादा होगी, राइट सब ट्री में अगर ज्यादा नंबर ऑफ नोड्स हैं तो हाइट ज्यादा होगी. नाउ द क्वेश्चन इज, लुक एट दिस पर्टिकुलर स्टेटमेंट यू नीड टू अंडरस्टैंड. इट्स अ वेट बैलेंस्ड ट्री. If it's a weight balanced tree, then the height of the tree should be around log n. But the question and its options are different in terms of base. Base should be what? 3 or 4 by 3 or 2 or 3 by 2. What should be the base of the log? That we need to decide, and it's very easy to decide. It is very easy to decide. Look at this. If I want to calculate value of x here or value of number of nodes in the terms of n, if I want to calculate number of nodes in the left and right subtree, total 3x number of nodes you are having, around 3x plus 1 number of nodes you are having. Among those you are having left subtree. You are having in the left subtree how many number of nodes? In the left subtree you are having, among 3x nodes you are having by 2 portion, and in the right side, okay, I should say 3n by 2 nodes in the left subtree, and in the right subtree you will be having 1n by 2 number of nodes. You can interchange it. Either you will be having left side 1 portion of 3 and right side 2 portion of 3, or vice versa, just because in the question they have mentioned कि एक तरफ at least half होंगे और या फिर at most होंगे double. So among 3 portions of your n number of nodes, 2 portions are one side, 1 portion is other side. Among this you guys are having okay, I need to make a little bit change, not like that way. So among 3 portion, 2n by 3 are here and 1n by 3 are here. In this particular case, what will be the log ka base? Log ka base will be based on which side you will be having maximum number of nodes. Look at this. Concentrate करिएगा, आपको बहुत अच्छी एनालॉजी समझ में आएगी. यहाँ पे एनालॉजी बहुत अच्छी से समझ में आएगी. Look at this. If we have height balanced tree in such a way that n by 2 elements are here, 1 by 2 of n elements are here, half elements are here, among n elements half elements are here, in that case maximum height of the tree can be what? Log of n base 2. Why? Just because you are dividing by 2 by 2 by 2 by 2 by 2 each side. Yes, division, the distribution of the nodes is equal in each side for every single node. If that is the case, this is the height, then in my case, in which I am having one side number of nodes 2 portion of 3 of n, one side number of nodes, 1 portion by 3 of n number of nodes. Can you tell me height? Maximum height can be what? Based on the maximum number of nodes, this one. So height should be log of n, but what this 2 by 3 or 3 by 2? 3 by 2, log of 3 by 2. Mathematically also we can see that in the algorithm chapter, we can see that this particular thing you will learn how to calculate that, but this is now very easy concept. आपको बहुत आसानी से समझ में आ जाएगा एनालॉजी की हेल्प से कि if you are dividing the number of nodes in two different equal halves, based on that you will be having log of n height with base 2. This time you are dividing the number of nodes in such a way, one side 2 by 3, one side 1 by 3, and hence in that case you are having what? You are having log base 3 by 2. Answer is D. Now you need to understand first the question. So whenever you read the question, you just distribute the number of nodes in such a way based on the question, and hence you will be able to understand that yes, अभी हम अगर half divide करेंगे, log of n base 2 आता है. Height, if we are not dividing half, we are dividing in such a way, then what will be the height? You can understand based on the maximum number of nodes in one side. I hope you understood this particular point. Now let's see next question. Next question says, consider the label sequences obtained by the following pairs of traversals on a labeled binary tree. Fine. Which of these pairs identify a tree uniquely? Which of these pairs can identify a tree uniquely? Pre-order and post-order? No, it cannot identify a tree uniquely. In order, post-order? Yes, it can. Pre-order and in order? Yes, it can. Label order and post-order? No. So second and third, option B is correct. Second and third, in order, post-order, in order, pre-order can identify or can give me a tree uniquely. Option B is correct. This is a very simple fact which we discuss in the classroom also. It's a very simple concept. ठीक है? Why pre-order and post-order cannot identify a tree uniquely, or why label order cannot help in the finding the tree uniquely? Just because these cannot distinguish the left subtree and right subtree uniquely. हमें left subtree और right subtree का idea नहीं होगा कि which particular node or this particular node is in the left subtree of the root or right subtree of the root. That is the problem. That is the problem. I hope you guys are understanding. Keep interacting, keep talking so that I can understand that you guys are listening carefully and understanding that how exactly we need to answer the question. Another question we guys are having. The question is, consider the following C segment. Find the value returned by function do something when a pointer of the root of a non-empty tree is passed as argument. So in this particular function, we have passed a tree's root as the input in the function. Input में हमने पास किया root का address as the input and the non-empty tree. Okay, so what exactly it is? First of all, they have given the structure. So structure is having left child pointer, right child pointer, and integer type element. Okay, fine. So do something function is this way. So for root, value is 0. Fine. Pointer is pointing to null or not, we are checking. Okay, so pointer is given, that is ptr is pointer to pointing to the root of the non-empty tree. Okay, so value is initially 0. Now pointer is not equals to null. Yes, not equals to null. Then we are checking if pointer ka left child is not equals to null, means pointer's left child exists, means root's left child exists. If exists, then we are calculating value equals to 1 plus do something. So we are calculating value is equal to 1 plus do something. Okay, fine. And if pointer ka right child exists, after that we are checking out if pointer's right child exists. So if pointer's right child exists means it is not null, then we are calculating value is equal to max of value comma. Value means previous value which we have calculated by the left subtree is call. So value is equal to max of value comma 1 plus do something. So this particular function is calling from the root. If we are having the left subtree existing, then we are calling for this one, we are calling for this one, and we are calling for this one, and what we are calculating 1 plus do something for this one. Then for right subtree we are calling 1 plus do something for this one, and after that we are checking that which one is maximum, this one or this one. Whichever is maximum of 1 plus do something with left child comma 1 plus do something with the right child, whichever is the maximum we are returning for the root. And if you have attended my recursion topic on the tree, if not, then please look at the data structure playlist under the same channel. Go for a specific session in that playlist which states that tree recursion on the tree. There I have explained that mostly you will understand, or you can understand the recursion on the tree using the base case. Here is what base case is. If suppose pointer points to null, then what happens? If pointer points to null, then in that particular case you will return value, means you will return 0. Means for empty tree, if you have called the function, then my function will return 0. Function will return what? 0. So function will return for empty tree 0, otherwise 1 plus do something with left subtree comma 1 plus do something right subtree, or दोनों का maximum. And we know that we calculate maximum for the height. So this particular session or this particular function is actually calculating the height of the tree when height of the tree is equal to 0 for empty tree. For empty tree, height will be 0. For single node, height will be 1, and so on. So this particular function calculates what? Height. Okay, fine. If you are clear, let's go for the next question. Next question is this: which one of the following binary trees has its in order and pre-order traversal as this one and this one? Very simple. Let's calculate in order and pre-order for all those 4 trees, and we will check out that which one is matching with these best. So let's calculate pre-order for this one. Pre-order for this one is first of all A, then B, then C, then D. Okay, so pre-order matching. Okay, in order is first of all B, then A, then D, and then C. BADC not matching. No, option A wrong. For this one, pre-order A, C, B, and D. Pre-order not matching, but let's calculate in order also. In order is B, C, A, D. Fine, in order matching, but pre-order not matching, not the correct option. This one, pre-order is A, B, C, and D. In order is first of all A, after that C, B, D. A and then C, B, D. No. So of course this should be correct. Let's check it out. Pre-order first of all A, then B, then C, then D. In order is first of all B, then C, then A, then D. How I am calculating this? How I can calculate this? How I will calculate this? It's very simple. In order says first of all left subtree, then root, then right subtree. So BC, then A, then D. Now BC in the order of left, root, and right. So BC, AD is the in order. Yes. Pre-order is ABCD. That's a correct option. D option is correct. Got it? Okay, fine. Fine. If you got this, let's go for another question. Here it is. In a binary tree, for every node, the difference between the number of nodes in the left subtree and right subtree is at most 2. Number of nodes in the left subtree and right subtree, the difference between left subtrees and right subtrees number of nodes is at most 2. At most 2. If the height of tree is h greater than 0, then minimum number of nodes in the tree is minimum how many number of nodes you can have in the tree. If you want minimum number of nodes in the tree, then keep the difference maximum. Keep the difference between left and right subtree maximum. अगर कम से कम नोड चाहिए तो रखो, कम से कम नोड रखो, एक तरफ कम रखो, एक तरफ ज्यादा रखो. Let's keep minimum number of nodes. How? One side you keep less, one side you keep more number of nodes, but difference of the number of nodes can be at most how many? 2. Let's make the tree. Let's make the tree height h greater than 0. So let's make the tree like this way. This is one of the example. Left side and right side height or number of nodes at most 2. Yeah, fine. This is fine. Yes, this is also fine. Is this fine? No. This is fine now. This is fine now. Why? Just because if this one, if we will not have the last node like this way, if we will not have the last node, this one, okay, for this node, left subtree is having 1, 2, 3 nodes, right subtree is having 0 nodes, difference is more than 2. So I should add another node here. Then I can go with this one. If I am adding this one, so I'll have to add one node here. How many nodes are there? 1, 2, 3, 4, 5. So I should have 3 nodes here. Like this way. Right. Now, how many number of nodes are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 number of nodes. How many nodes are there? 1, 2, 3, 4, 5. How many number of nodes? 1, 2, 3. What is the height of this particular tree? Height of this particular tree is 2 or 1? 1 or 2? 1 or 2? 1 or 2? 1 or 2? You will have to check it out. You will have to check it out. You will have to check it out. Now, which definition you are going to have for this one? Height of this particular tree can be 2 or in fact can be 3. Height of this particular tree can be 0, 1, 2, 3 or 4. So height of the tree can be 3 or 4. Height of this particular tree can be 4 or 5 based on 2 different definitions. 2 different definitions. See, look at this. The difference between left subtree and right subtree's number of nodes should be maximum 2, not more than that. So if you are not able to understand how to draw such kind of tree, look at this. Take this particular tree. Take this particular same tree. Okay. If I have taken the same tree, let's increase the height. If I have increased the height, then for this node, left subtree is having 1 node, right subtree having 0 node, difference is yes at most 2. For this one, left subtree is having 2 nodes, right subtree 0 nodes, at most 2. For this one, left subtree is having height or number of nodes 3, right subtree is having number of nodes 0. So what I'll have to add is 1 node I'll have to add here so that number of nodes ka difference can be 2. For this node, how many number of nodes are there in the left? 1, 2, 3, 4, 5. If 5 nodes are there, then for the root, right subtree should contain how many number of nodes? 3 nodes at least. So that the difference can be at most 2. So how I can have 2 nodes? Like this way I can have 2 nodes. Or like this way also you can have 2 nodes. Anywhere you can add. Just take 2 nodes that side. Total number of nodes, how many? Total number of nodes 5 plus 3, 8 plus 1, 9. Height of this particular tree can be if we are starting from 0, 0, 1, 2, 3, 4. Or if I am starting from 1, 1, 2, 3, 4, 5. Right? So based on this, if we are having 4 or 5, based on that we can calculate the number of nodes. So if we are taking height 4, I can write it like this way, 2 power h minus 1 plus 1. 2 power 3, 8 plus 1. Here if we are taking height 3, then 2 power h minus 1, which is 2 power 2, 4 plus 1. Here also 2 power 2 plus 1. Hence, I will go with the first definition, and option I will be having this one. I cannot go with this particular definition. Why? Just because if we will take the definition of the height as the number of nodes or height of the tree with single node is 1, in that case no formula will match with us. No formula will match with us. Got it? Understanding? Understanding or not? If understanding, well and good, superb, amazing. Next one, another question which is again very simple question. Very simple. See, you need to understand the requirement of the question, right? It's very simple thing I want to tell you now. It is out of the context, but definitely it can help you a lot. As soon as you step into a shop, suppose the shop is of a particular fashion shop, okay, and it's not a window shopping, it's a shop of a very old old type of store or very local type of store, where you ask the shopkeeper and shopkeeper will give you the item. ये देखिए भाई साहब, ये देखिए बहन जी, ये देखिए, ये देखिए, ये देखिए, and they show to they show the customers the items. This is not the window shopping that everything is available for you, just check it out. No, ऐसा नहीं है. So in that particular case, if you step into the market or in a particular shop, the fellow will directly say or see you, and that fellow will show, देखिए भाई साहब ये शर्ट ले लीजिए, ये टी शर्ट देख लीजिए, ये देख लीजिए. No, that fellow ask you what do you want, what exactly you want, आपको चाहिए क्या, right? And this is exactly what you are going to do for each and every gate question. You are a shopkeeper, gate question is the customer. You just read and understand what exactly that gate question is asking. Based on that only you show the material. देखते से ही कुछ भी नहीं दिखाना, अच्छा ये आ रहा है, इसके पास जीन्स फटा हुआ है, जीन्स दिखा दो उसको, ऐसा नहीं करना है. So try to understand the requirement of the question, and based on that you try to solve the question. Definitely you will understand my point once you will write some test, and definitely you will understand my point when you will write the gate exam. Okay, चलिए वापस आते हैं पॉइंट पे. A scheme for storing binary tree in an array X is as follows. Indexing of X starts at 1 instead of 0. Fine, we know some kind of array storage of the tree. हमने पढ़ा है BST में और complete binary tree CBT में. But again, the same thing they are trying to give us. The root is stored at x of 1. Yes, we know that instead of 0, we will store the first node at 1, and after that its left child. So for a node stored at x of I, the left child, if any, is stored on x of 2i on the 2i index. And if any node is stored on index I, then its right child will be stored on 2i plus 1. Now the question is what? Read this line very carefully. To be able to store any binary tree, not complete binary tree, any binary tree on n vertices, means n nodes, the minimum size of x should be, array x should be. So the question is, if I want to store any binary tree of n vertices, then how much size array I should have, so that I can ensure that yes, any type of binary tree I will be able to store, right? Okay, fine. Now look at this. Let's take a simple example. If n is equal to, suppose I have taken 4, so I should be able to store any binary tree of 4 nodes in the array. So the binary tree can be this much, the binary tree can be this one, 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 binary tree can be this one. Any binary tree which I want to store, I can store in that array if I have this much, some kind of minimum size of array. So in that particular case, if I want to store any binary tree of n vertices, I want to go for the worst case. कि कौन सा ऐसा, which particular tree will go for the worst case, and the worst case is this one. This will take my array to the worst case. How? 1 is the index of the root. Okay, let me draw it in the proper way. This is my worst case. Why it is worst case? Just because look at this. Here it is. Root. Its right child is stored on 1 into 2 plus 1, 3. Right child 3 into 2, 6 plus 1, 7. 7 into 2 plus 1, 15. Its right child will be stored on index 15. So array should be of 15 size, so that I can store the worst case binary tree. The worst case binary tree. So on index number 1, I will be storing the root, this one. Then on index number 3, I'll be storing the next value. On index number 7, I'll be storing next value. And on index number 15, I'll be storing the next value. Like that way, you can have your array representation of this tree. So any tree of 4 node you can store in the array if you have minimum array size 15. 15 से ज़्यादा होगा. If you have more than 15, fine, no problem. But less than 15, might possible you cannot store any or some of the binary tree with n vertices. कोई binary tree हो सकता है जो आप store ना कर पाओ. That's why the answer is 15 for n equals to 4, which is nothing but 2 power n minus 1. So you need to understand the requirement of the question, and based on that you need to attempt the questions in the gate, in the test series, everywhere. Another question, here it is. An array X of n distinct integers is interpreted as a complete binary tree. Okay, so complete binary tree means what? Complete binary tree means the binary tree in which each level has maximum number of nodes. Each level is full, maximum number of nodes except possibly last. And on the last level, you will be having nodes arranged from left to right. That is the complete binary tree. So what it says, an array X of n distinct integers is interpreted as complete binary tree. The index of first element of array is 0. Oh, so usually we have seen that index of array starts from 1 in the array representation of CBT, complete binary tree. But here they have index starts from 0. Fine, no problem. We don't have any problem with that too. We can interpret some answers through that only. चलिए देखते हैं कैसे काम करेगा. Now what they are saying, the index of parent of element x of I when I is not equals to 0 is. So suppose you have a CBT. Let's take an example. Through example, this particular question will work best. So let's take an example like this. D, E, F, G and H. This is the example I have taken. Now we know that the array representation of CBT is what? Starting index is 0, then 1 here, 2 here, 3 index, 4th index, 5th index, 6th index and 7th index. Like this way the presentation or representation will be. Means in the array the elements will be stored like this way. First of all, A will be stored on index number 0, B will be stored on index number 1, C will be stored on index number 2. Similarly, D will be stored on index number 3, then 4 पे मिलेगा आपको E, then index number 5 will be having F, index number 6 will be having G, and index number 7 will be having H. This way array will be stored. Now if I am asking, I is not equals to 0, if I is equal to 1 or I is equal to 2, दोनों के लिए, for these two, the parent is 0. The parent is 0. How can I get the parent if I is equal to? How can I get the parent if I equals to 1 or 2? The parent is 1 by 2 0, but 2 by 2 is not 0. The 2 by 2 is not 0. Okay, so let's take it like that way. So I by 2 and floor value gone. Option is gone. I minus 1, 1 minus 1, 0 divided by 2, 0. Fine. I minus 1, 2 minus 1 divide by 2 is 0.5 and its seal value is 1. Wrong. Gone. Gone. Why? See, 1 minus 1, 0. 0 divided by 2 is 0. Fine. Fine. For this one, fine. This one, 2. If I is equal to 2, 2 minus 1 is 1 divided by 2 is 0.5 and its seal value. Look at this. This is the seal value and here is the floor value. These are the two functions, right? So it's a seal value. Seal value 0.5 का seal value होगा 1. So B option also gone. We want 0. I by 2 का seal value. 1 by 2 का seal value is 1 by 2 is 0.5. Seal value is 1. Gone wrong. So this should be correct answer. Let's see. I by 2. 1 by 2 0.5 का seal value is 1. Minus 1 is 0. Fine. I by 2. 2 by 2 is 1. Minus 1 0. Yes. Working fine. For this one also we can check 3 and 4. 3 and 4. 3 by 2. 1.5. Seal value is 2. Minus 1 is 1. Fine. Yes. Fine. 4. 4 by 2. 2 seal value is 2 minus 1 1. Yes. 5 6 के लिए भी काम करेगा. So D option is correct to get the parent if we start the array indexing from 0. This works best when you take examples. Example लो, formulas लिखो, formulas से आपको समझ में आ जाएगा easily that how these formulas will work. Use the formula and get to know the answers that if the formulas are working on your examples or not. Very simple, very simple. Okay, चलिए आगे बढ़ते हैं. अगला प्रश्न ये रहा अपने कंप्यूटर सिस्टम पे. Okay, question is what is the difference but with option A and option C? See, option A and C, A says that it's a floor value and B, C says it's a seal value. Floor value means if you got 0.1 and its floor value will give you 0. But if you get 0.1 and its seal value means upper integer, it gives you 1. So if you get any real value, not the integer one, any decimal point value, if you are getting any float value, then the floor function gives you the minimum means nearest minimum integer and seal gives you nearest maximum integer. That is the difference. चलिए आगे बढ़ते हैं. अगला प्रश्न ये रहा आपके स्क्रीन पर. अगला प्रश्न, दिस इज अनदर क्वेश्चन, अनदर जेम ऑफ द क्वेश्चन. An array X of n distinct integers is interpreted as complete binary tree. Same to same as it is. The complete index, the index of the first element of array starts from 0. Fine. If the root node is at level 0, fine. The level of element x of I is what? When I is not equals to 0. Fine. So let's take same example. वही का वही example हम यहां वापस से लिखते हैं. A, B, C, D, E, F, G, H. Fine. Now array representation. Array representation of the same tree. Fine. So array indexing 0, 1, 2, 3, 4, 5, 6 and 7. So here is the array representation. A, B, C, D, E, F, G and H at index 0, 1, 2, 3, 4, 5, 6 and 7. Now what is the level number? Level number they said starting from 0. So this is level number 0. This is level number 1. This is level number 2. And this is level number 3. What they are asking? If any element is given on index number I and which is not equals to 0. Means let's take this one. If element at index 1 and 2 are given, I need to give the level equal to 1. Level equal to 1 for 1 and 2. For 3, 4, 5, 6, I should give the level 2. For 7, 8, 9, 10, 11, 12, 13, 14 something up to level number equals to 3. चलिए देखते हैं कैसे होगा. Suppose for 1 and 2, let's test for 1 and 2. For 1 and 2, I should get level number 1. Okay, so I am taking this one. Option A, log of I. Log of 2 is equal to 1 on base 2. 1 and its floor value is 1. Fine. Log of 1 on the base 2 is less than 1. Is less than 1. Yes or no? Yes or no? Yes. Less than 1 and its floor value gives you 0. Wrong option. Yes, wrong option. Now next this option. Let's see. Log of 2 I plus 1. Log of I plus 1 base 2. Okay, I is 1, 1 plus 1 2. Log of 2 base 2 is 1. Its seal value is 1. Fine. For this one, working fine. For 2, if index is 2, 2 plus 1 3. Log of 3 base 2 is more than 1. Definitely more than 1. 1 point something. Now 1 point something in its seal value. Here it is the seal value. Seal value mean it gives you 2. Okay, no, level number is not 2. Level number is not 2, level number is 1, so it's wrong. Option B also gone wrong. Option B bhi gaya. Now next option, option C. Option C there says that I plus 1 log 2 and its floor value. Okay, I plus 1, 1 plus 1 2. Log of 2 base 2 is 1. Its floor value is also 1. Fine, working fine. For 2 plus 1 3. Log 3 base 2 gives you 1 point something. Log 3 base 2 gives you 1 point something. Why? Just because log 4 base 2 gives you 2. So log 2 is 1, log 4 is 2. So log 3 जो होगा 1 point something होगा between 2 and 1 and 2. Right? So 1 point something, its floor value means 1. Right? So C option is looking correct. Let's check it out for this 3, 4, 5, 6 also. Let's check out for minimum value at least and maximum value at least. 3 के लिए check करते हैं. 1 I plus 1, 3 plus 1 4. Log of 4 2. Fine. Floor value 2. Yes, fine. No problem. Log of 5 2 point something, floor value 2. Log of 5 2 point something, floor value 2. Log of 6 floor value 6 plus 1 7. Log of 7 floor value 2 only. So yes, C option looks correct. Let's check it out D option also. Log of 2 log of I and its seal value. काम नहीं करना चाहिए. कैसे? Log of 1. Log of 1 is what? 1 point something or 0 point something? 0 point something. 0 point something. And its seal value 1. Fine. काम कर रहा है. Right? And log of 2 seal value is 1. काम कर रहा है. But क्या इनके लिए काम करेगा? Let's check it out. Log of 3 and its seal value. Log of 3 is 1 point something 2. Fine, no problem. Log of 4, fine. Log of 5. Log of 5 will give you 2 point something and its seal value will give you 3. Means for this particular level it will not give you correct answer. So D option gone wrong. You need to check out very simple thing. What? You need to check out very simple thing. That is what? It's very simple thing that all the options you need to check. All the options you need to check. Got it? Understood that? If you don't understand how to calculate log, you can go with this way also. Log of 4, if I am saying base 2 means 2 की power what? So that you can get 4. X. So when I am saying that log of 1 I am calculating and that is equal to base 2 is equal to x, means 2 power what is equal to 1. So log of 1 can give you 0, simple. Log of 1 is equal to 0, simple. चलिए आगे बढ़ते हैं और क्वेश्चन है हमारे पास. इन अ बाइनरी ट्री द नंबर ऑफ इंटरनल नोड्स ऑफ डिग्री 1 is 5 and the number of internal node with degree 2 is 10. Now binary tree, and what is the degree? Degree is nothing but number of children. Degree is nothing but number of children. So we have in the question given, we have some internal number of nodes with one child is equal to 5 and internal nodes with two children is equal to 10. Question is the number of leaf nodes in the binary tree is how many? Based on our handshaking lemma, we know in the binary tree total number of leaf nodes is equal to number of internal node with two children plus 1. सो आंसर शुड बी 10 प्लस 1 11. अब ये कैसे आता है? आप इजीली जस्ट चेक आउट माय वीडियो ऑन अनअकैडमी कंप्यूटर साइंस चैनल ऑन दिस पर्टिकुलर चैनल इन डेटा स्ट्रक्चर प्लेलिस्ट. गो टू डेटा स्ट्रक्चर प्लेलिस्ट, गो टू प्लेलिस्ट सेक्शन, डेटा स्ट्रक्चर में जाके और मेरे ट्री लेक्चर को देखो. फर्स्ट लेक्चर में आई गेस और इन द सेकेंड लेक्चर इन द बाइनरी ट्री लेक्चर आई हैव एक्सप्लेन दिस दैट हाउ एग्जैक्टली दिस पर्टिकुलर formula comes into the picture. I am not giving you only formula every time. I have given a really explanatory description about this particular lemma. Okay, चलिए another thing, next question. अभी क्वेश्चन खत्म नहीं हुए हैं रे बांगड़ू, आगे बढ़ेंगे और भी क्वेश्चन है हमारे पास. The height of a binary tree is the maximum number of edges in any route to the leaf path. Number of edges they are calculating, means if you are calculating number of edges in this particular tree, number of edges from root to the leaf, then answer is 2, means single node height is 0 and then further you are having further. Okay, single node height 0, single node height 0, single node height 0. Okay, so if single node height 0, then what they are asking, maximum number of nodes in a binary tree of height h is what? Maximum number of nodes in a binary tree of height h is what? Suppose this is the tree. Maximum number of nodes if we want, then this is the tree of height h is equal to 2. Maximum number of nodes n max is equal to 7. Then if we have height 3, then maximum number of nodes, how can we have? How many we can have? 15. How many we can have? 15. H is equal to 3. Answer is n max is equal to 15. So which particular formula is correct here? Which particular formula is correct here? Which particular formula? This is 2 power 3 minus 1. This is 2 power 4 minus 1, means 2 power h plus 1 height plus 1 minus 1. Option C is correct. Option C is correct. Okay, you got it. This one, this one, this one, this one, this one. सारे के सारे questions आपको समझ में आ रहे हैं. If you guys are getting this, then definitely you will be able to understand every single thing. And I would love to see you guys solving the GATE question in your GATE exam 21-22, whichever you are going to attempt, with this much ease only if you understand how to solve the questions. Another one, the maximum number of binary trees that can be formed with 3 unlabeled nodes is. ये बहुत सिंपल क्वेश्चन है, very simple question. This is how many maximum number of binary trees can be formed with 3 unlabeled nodes. What is unlabeled? Unlabeled means there is no any key, there is no any value on the node. So 3 nodes are there. How many number of trees you can form with 3 nodes? 1, 2, 3, 4 and 5. एंड 6। नहीं, ऐसा नहीं होता है। ऐसा भी कोई ट्री बनता है क्या? ऐसा भी कोई ट्री बनता है? नहीं 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 सर, ऐसा नहीं बनता है। सो आंसर इज 5, बी करेक्ट। Yes, 5. Exactly. Now, if the question will be asked for n equals to 4 or 5 or 6 or 7 or 8, then it becomes very difficult for you to form each and every tree. So, for that, we have a really interesting formula here for n unlabeled nodes. आपको याद है formula for n unlabeled nodes? The number of binary trees which can be formed is equal to Catalan number, and that is equal to 2n cn divided by n plus 1. It's a Catalan number. This particular Catalan number maps to one of the problem in the stack also, which is called as stack permutation, and there are so many such kind of problems on which this Catalan number formula maps to. So how many unlabeled binary trees you can, or with n unlabeled nodes, how many distinct binary trees can be constructed or formed? Answer is Catalan number 2ncn divided by n plus 1. Fine. In this one we have given, or I have given you in my classroom training, a variation also, a variant also. If n distinct keys are given, how many binary trees can be constructed? N distinct keys are given. If n distinct keys are given, then these are the structures, these 5, and in each structure you can populate the keys with n factorial way. That's why with n distinct keys, my answer should be this much into n factorial. But unlabeled nodes दे रखा है क्वेश्चन में, we will go with option B 5. Okay, clear, cool, understandable? समझ रहे हो या नहीं? बहुत लेट हो गया, I know that, but you are the engineers, and I know that if engineers decide that you want to go for something, then they will surely make that possible, whether it is assignment writing of 100 pages in just 3 hours, or whether writing a lot in this 3 hours semester exam, or whether it is cracking the gate exam with maximum marks. If you decide, you go for that one. So I know that you guys are really passionate people. That's why you are awake in the night till the late. You are awake in the morning, in the early morning for all the sessions, and you guys are very enthusiastic, and we get motivation out of it. But we need more motivations. If you can share these videos with all of your friends, if you come to this particular lecture, if you come with this particular lecture and every time you like the session, that will help us a lot, gives us lot of motivations. Once you are done with the video, come back here, drop the comments over the videos. All these things help us a lot, motivates us a lot, and in terms we will reflect all these motivations in terms of such kind of quality educations for you guys. Really sorry for that. This is another question. You can also try to solve this question. The in-order and pre-order traversal of binary tree are given. The post-order traversal of the tree is what? In order, and so this is in order, this is pre-order. We need to form the tree. We know that pre-order traversal, first symbol is root, so we have root is A. Fine. If root is A, DBE should go in the left side. Right side should be O, it should be DBE. And right side should be FCG. FCG. Now check out DBE. DBE here, the first symbol is B, means B comes as the root of this subtree. So root of this subtree is B. Fine. In the in-order traversal, before B, D comes, means D should be in the left. E comes after B, means E comes right. Right subtree FGE. FGE is the right subtree. FGE में first symbol in order pre-order traversal. Pre-order traversal among FCG. FCG में first symbol is C. First symbol is C. Oops, my mistake, my bad. There is a mistake I made here. Okay, fine. So what I will do is, first symbol in order traversal is, oh, I was correct. B was only the root. Fine. In the in order traversal, D is the left, right is E. Fine. In FCG with pre-order traversal, the first symbol is C, so C is root. C is root. Left subtree is having F, right subtree is G. Okay, so this is the tree. Pre-order traversal ABDE. In order traversal is DBE. AFCG. Yes, correct. Post order traversal is what? Post order traversal is DEB, then FGC and A. DEBF, DEBF, GCA. Option A seems correct. Option A is correct. Yes, Subhashri. Yes, correct. Yes, correct. Okay, fine. So this is one of the very basic question which we discuss in the classroom training also, that based on the in order pre-order construct the tree and get the other traversal or any other question. Once you draw the tree, there are n number of questions can be asked. रूट के लेफ्ट में कितने हैं, राइट में कितने नंबर ऑफ नोड्स, व्हाट इज द हाइट, हाउ मेनी लेवल्स मैक्सिमम, दिस नोड कम्स ऑन विच लेवल, एंड देयर आर सो मेनी एन नंबर ऑफ क्वेश्चंस कैन बी आस्क्ड. वन ऑफ द क्वेश्चन इज अदर ट्रैवर्सल. Fine. चलिए, another question we are having. That particular question again is very easy question, just because it is based on the traversal. It is based on the traversal. What traversal? Tree traversal. How? Just because it's a recursion. What it says? First of all, cell node is given, okay, and then structure of the node is given, left child pointer, right child pointer, and integer element. Now there is a function called as get value function, and what they say, what this get value function return when a pointer to root of binary tree is passed as argument. So when we are calling this one, what is the value returned by the function? Look at this. If you will check out the function, you can understand it easily that what is returning. You don't have to run the function at all. Look at this. Value is initially 0, right? When pointer is not null, means pointer is pointing to a valid tree. First of all, you are checking if pointer ka left child is null, right child is null, means pointer is pointing to a leaf node. Then value comes as 1. When this is the base case. When pointer is pointing to a leaf node, value is equal to 1. If pointer is not a leaf node, then you are calculating value by calculate get value from left child plus calculate value from right child and return it. Initially value is 0, so this addition will not affect much. So exactly what we are doing. For leaf node, return 1. Otherwise, from any node, internal node, calculate something from left side plus calculate something from right side and return it. Ultimately what it is returning? Leaf nodes. So what this particular function is, if we are calling the function with pointer, we will check that pointer is pointing the leaf node. Yes, then return 1. If not, then calculate number of leaf nodes in the left subtree, then calculate leaf nodes in the right subtree. इसमें suppose some x number of nodes, इसमें suppose y number of nodes, leaf nodes, then total leaf nodes will be x plus y. This is what they have written. Get value from left child and get value from right child. So answer is this function returns leaf nodes. Fine. If you are not understanding how to understand the recursive approach or recursion on the tree, then I would recommend you to watch a particular session in my data structure series playlist, which is recursion on the tree. Please go and watch that. Definitely you will understand how to understand the recursion over the tree. चलिए, तो आज का सेशन यहाँ पे हुआ खत्म. टुमारो वी आर गोइंग टू हैव रेगुलर सेशन एट 7 PM ऑफ डेटा स्ट्रक्चर, इन विच आई एम गोइंग टू टॉक अबाउट द binary search tree. Very special topic it should be, so you need टू अटेंड इट विदाउट एनी फेलियर। आपको ये सेशन अटेंड करना ही करना है। बहुत 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 इंपॉर्टेंट सेशन होने वाला है, जस्ट बिकॉज दिस पर्टिकुलर सेशन इज गोना हैव लॉट्स एंड लॉट्स ऑफ इंफॉर्मेशन टुमारो। एंड अपार्ट फ्रॉम दैट 12 PM regular DS PYQ session I am going to have, so that you can have more questions on the tree data structure, which is part number 3. Sure. Okay, fine. Okay, so don't worry about that. All the PDFs I will drop now only on this particular channel. So on this channel you will be getting the PDF of all the lectures, including this one and whatever I have taken previously. Don't worry, I will drop these particular PDF on this particular channel. But for that, for motivating us, you need to spread the word about this particular package which we are providing on this channel as a team. So this is a proud members team. This particular team is the team of those members who have cracked any kind of any kind of exam. कोई तो एग्जाम किसी ने तो क्रैक किया हुआ है. These are all experts. These have cracked some of the exam and they are topper of those kind of exam like GATE exam or maybe NET exam or maybe ISRO or other PSU exams. So rely on this particular team. Spread the word about this particular team to all of your friends. Share their videos, their playlists, their channel, and every single thing you need to do for us. Yes, you need to do this particular thing. Why? Just because we want that every single person who is seeking for the quality education should be connected with us, so that we can be eligible to teach them. We can be allowed to teach them with the highest quality of explanation and understanding. For that, you need to help us to reach out each and every student of this country of computer science to understand these topics up to the maximum level. And if you want to be connected with us on Facebook, please join these Facebook pages. And one more thing you need to do is, it's not only up to computer science we are limited to, we are into multiple domains including ECIN electrical. With the Creatrix channel we are spreading the quality education. GATE AMI PIXC for mechanical, CE for civil, this particular your own channel, computer science channel, engineering Pathshala channel for the animated video, SSC JE channel for the SSC JE junior engineer exams, GS terminal for GS general studies. So all these channels you need to make approachable and you need to make famous among all those students who are in the need with the highest level of preparation. Sure. Okay, fine. So thank you so much for joining here. One last words from my end. Every time you come for the classes, please like the video. Either you are watching this particular lecture live or offline. Every time you like the videos, share the videos, playlist and the channel. Subscribe the channel if you haven't till now. And ये bell icon दबा दो ताकि जब भी मैं क्लास लेने आऊँ आपके फोन की घंटी बजे. Happy learning everybody. Keep learning happily and make your learning happy. Thank you so much for joining here. Good night. We will see you soon. Till then,